Hello and welcome to the Daily Space for today, June 13th, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain and to forget to unmute the show at the very beginning. Welcome, everyone. Now, some of you have heard me lament on many days that it's just a slow news day and there's not a lot of new information coming out. Well, today, this is what I faced in my inbox when I went to see what are the latest press releases. Now, you're not expected to be able to read this, but I want you to know this is a screen capture of all the press releases that have come out since yesterday's Daily Space, and there's a lot. And this means today we are going to do a Who's Got Time for That style roundup of the news, zipping past everything. And we are going to be coming back to some of these stories on later days when things are going a little bit slower. For instance, I know that there are two press releases right now about the South Aiken Basin on the moon. This is the giant crater in the south pole of the moon, where they now think they just might have found the heart of the asteroid that caused all that, well, cratery carnage. There is also a new paper out in Nature Geosciences about how they think they understand how Vesta got its giant polar basin as well. So I'm going to be bringing on a pair of scientists to help you understand all of that, but not today, because who's got time for that? So in other news, today, Chairwoman Bernice Johnson, a Democrat of Texas, and Congresswoman Jenniffer González-Colón, a Republican from Puerto Rico, introduced H.R. 3196, an act that will rename the Large Synoptic Survey Telescope currently under construction in Chile as the Vera Rubin Survey Telescope. Now, for those of you who don't know, Vera Rubin is a woman who, like many women before her, did Nobel Prize-worthy research that she didn't get a Nobel Prize for. Specifically, she is the person who figured out there's dark matter out there and dedicated her entire career in one way or another to continuing its study. So, it's kind of awesome. And while I personally have problems with renaming telescopes before they've seen first light, that's a superstitious thing a lot of us astronomers have. James Webb Space Telescope has only reinforced our superstition on this matter. We are hoping that the Large Synoptic Survey Telescope will accept this name, wait to use it until it's seen first light, and we'll see first light, well, whenever it's now supposed to see first light, because it was supposed to see first light a few years ago. So who's got time to figure out when telescopes are going to see first light? There's still more science to come. In this story coming to us from Gemini Observatory, the South Chilean edition, they have just completed a survey of 531 stars, not too different from our sun. And they've been looking to try and figure out how it is that both Jupiter-like stars and not stars, Jupiter-like planets and brown dwarf stars form around, well, regular everyday suns. And what they're realizing is brown dwarfs and Jupiter-like planets have completely different formation mechanisms. Low-mass stars, sun-like stars, and brown dwarf stars, as we had previously had hints, all appear to form in a similar star-like manner, where you take a cloud of gas and dust, you set it spinning and collapsing in a star of one species or color or another forms in its center. Planets, on the other hand, form in the debris disk that surrounds these forming stars. Now, you can get a cloud that is collapsing that segments into two different concentrations of material. And each of those concentrations of material will form its own stars with its own potential planets around them. But you don't have one collapsing cloud with one concentration in the center that forms in its disk a star. Just doesn't happen. Now, while we are lucky enough to have Jupiter, Saturn, the slightly smaller Uranus, and Neptune, these giant worlds in our solar system, more results from this particular study show that these kinds of giant planets are fairly rare, but when they do form, they tend to form in a sweet spot, well, between 3 and 10 astronomical units. That's the distance between Earth and the Sun away from their star. This means that where Jupiter and Saturn are is statistically completely normal. The more systems we see, the more we know. This is a story we are going to be coming back to in another episode, but today we have no time for this because we have news about our own Milky Way galaxy. Our galaxy is not as plain Jane, flat, smooth, non-traumatized as one might wish for their host galaxy. Our galaxy is actually a kind of violent place. We know that it eats other galaxies. We know that it has galaxies flying past it, distorting its shape. And in new research, we have found that the Antlia 2 dwarf galaxy, which was found in the second data release of the Gaia spacecraft, well, it looks like this particular dwarf galaxy is the remnants of a past dark matter rich system. And when this extraordinarily dark rich matter system swooped past our galaxy, it distorted the disk, creating standing waves that we're now able to see in the density distribution of where stars can be found in the sky. So as they say it in the press release, Antlia 2's current location closely matches the location of a dark matter dominated dwarf galaxy that Chakrabarty predicted in 2009 through a dynamical analysis. Using the Gaia data, his calculated and past trajectory, they found that the Antlia 2 would have crashed into the Milky Way and produced the large ripples that we see in the outer gas disk of our galaxy. What this means is someone with amazing modeling skills looked at our galaxy, looked at the ripples, figured out this is what had to happen to get there, and now we've seen it in the Gaia 2 data. So this is kind of awesome. I'd love to talk more, but no, we have more news. This news comes to us about our sun. Now, like making any weather predictions, trying to predict what the sun is going to do in the long range is tricky business, and we don't always get it right. And in fact, we usually get it wrong, but we're trying, and we have more data than we used to have. And we think we can make predictions. I don't think we can make predictions. Other people think they can make predictions, and I'm going to wait and see if they're right or wrong and have no opinion. As they say in the press release, the last astronauts of the Apollo program were lucky, not just because they were chosen to fly to the moon, but because they missed some really bad weather en route. This wasn't a hurricane or heat wave, but space weather, the term for radiation in the solar system. Now, using our latest and greatest telescopes that are observing the sun in so many different wavelengths from so many different angles and directions, NASA scientists have worked to put together a prediction for the next decade. And what they find is the sun's activity rises and falls in an 11-year cycle. We knew that. We knew that a lot. The forecast for the next solar cycle says it will be the weakest of the last 200 years. This means fewer aurora, fewer amazing things that might send the astronauts seeking cover. The maximum of this next cycle, measured in terms of sunspot number, a standard measure of solar activity level, could be 30 to 50% lower than the most recent one. The results show that the next cycle will start in 2020 and will reach its maximum in 2025. Now, the reason that this is so important is we want to send astronauts back to the moon, or at least Vice President Pence wants to send astronauts back to the moon by 2024. And we don't have a way to protect them from radiation yet. So if we want to keep them safe, we want to send them there when the sun is quiet. We don't always have the kinds of warnings that we want, that a coronal mass ejection is coming. And this research hints that, well, maybe like planning a cruise through the Gulf Coast during hurricane season, if you're predicting a lower than average hurricane number, you're probably okay. If you're planning to go to the moon and you're predicting a lower sunspot than normal, you may be okay. But as with all things, exact timing matter, and predictions may or may not be accurate. Okay, I could go into the stats on that, but there's still more science that needs to be discussed. These results come to us also from that Gaia data I brought up a few minutes ago. So we already discussed Jupiters tend to come at a distance of 3 to 10 astronomical units away from their stars. They were observed with this telescope. And here's more information on these stats. Did I mention there's a lot of data released today? We suspect that in our solar system, Jupiter and Saturn sculpted the final architecture that influenced the properties of terrestrial planets such as Mars and Earth, including basic elements such as life and the delivery of water, says Frank Marchese, a senior researcher at the SETI Institute. He goes on to say, a planetary system with only terrestrial planets, which is what you will get because Jupiters are rare most of the time. A system with only terrestrial planets and no gas giants will probably be very different from ours, and this could have consequences for the possibility for the existence of life. So, yeah. Those Jupiters that we find mostly at 3 to 10 AUs, awesome. Those systems we find with no Jupiters, maybe less awesome for life. But we don't know yet because we don't quite know where life comes from yet. These are things we're figuring out. But I don't have time to discuss the search for life because there is still more science. Oh my God, it doesn't end. Okay, in news coming to us from Lawrence Berkeley Labs, scientists have begun to think that since we're not finding extremely heavy particles that we can call dark matter, we need to start looking for little particles we can call dark matter. So the experiments being done to seek dark matter candidate particles in particle physics experiments are changing. Instead of simply using instruments like CERN, like the Tevatron up in Chicago, scientists are going to be building much smaller experiments using detectors like the one you can see here in a researcher's hands. And these new and nimble experiments are going to look and see, have we been looking in the right place for dark matter? Or is it maybe that all that dark matter that's out there is made up of particles way smaller and lighter than anything that has thus far been predicted? This falls into the category of when you rule out everything you thought was possible, look for the impossible. Well, small, light, dark matter particles aren't impossible, but, well, we're starting to rule out the big stuff. So let's look somewhere else. Yeah. That's what we're going to do. But I don't have time to talk more about this because I have news that scientists reanalyzing the data from the Galileo space probe that used to orbit Jupiter before it went to a fiery death in 2003. Well, astronomers reanalyzing the data that the Galileo probe took of the moon Europa have figured out that on Europa's surface, there is table salt. I'm not quite sure what to do with this information, but it's kind of cool that you can say there's table salt on Europa, just in case you need table salt while you're exploring the Jupiter system. And finally, in our last news story for today, before I take your questions, remember to at me with your questions. We have a photo release from the Hubble Space Telescope. As they say in the press release, nestled within the field of bright foreground stars lies ESO 495-21, a tiny galaxy with a big heart. ESO 495-21 may be just 3,000 light years across, but that is not stopping the galaxy from furiously forming huge numbers of stars. It may also host a supermassive black hole. This is unusual for a galaxy of its size and may provide intriguing hints as to how galaxies form and evolve. Now, just to be clear, this is not a galaxy of unusual size. This is a galaxy that, like so many, in fact, the majority of galaxies out there, is kind of small, 3,000 light years across. And this small galaxy, what it is a star producer of unusual amount. It is producing massive amounts of stars. Located about 30 million light years away in the constellation Priex, this particular galaxy is creating stars 1,000 times faster than our Milky Way galaxy. Yeah. So we're producing 1 to 5 stars a year. This little tiny system, that would mean it's producing 1,000 to 5,000 stars a year. Yeah. This is crazy and awesome and unlike anything else we've ever seen. I expect that we will be learning more about this in the coming years as people continue to try and understand exactly what it is that we're looking at. Okay, that was a lot. We will be following up on those new results from Gemini South, where they have done that survey of 531 different sun-like stars and looked at the planets and companion stars going around them. We will also be continuing to see what new updates come on all the other stories I have just, quickly brushed past today. Now, please, I know you're going to have questions. At me in the chat, and while you type those in, I'm just going to remind you, The Daily Space is a production of the Planetary Science Institute working in collaboration with Youngstown State University. You can catch us most Mondays through Fridays at 1 p.m. Eastern, that is 10 a.m. Pacific, 6 p.m. London time. If you like us, can you support us? We are here thanks to the financial contributions of generous people like you. We pay our bills with your bits, subs, donations, and patronage over on patreon.com/CosmoQuestX. Anything you can give is really appreciated. And if you can't support us financially, I totally get it. I had to cancel my monthly donation to our local Australian Shepherd Rescue because it's just not a good month. I get it. But there's other things that you can do. You can promote us to your friends, inflict us on others, and help build our audience. And one of the ways around here that we will say thank you for your bits is to throw treats to a dog. Stella, come here. Come get it. Eddie's out in the yard somewhere. Stella is just staring at me. Here she comes. Come on, Stella. You got this. Slowly coming. She's the least food interested dog ever. Okay, so thank you. You allow me to pay the bills, including paying Annie a fair living wage. Okay, so Ed asks, where can I get the image you used of the telescope with all of the stars and galaxies in the background? I would love to have that as a desktop image. I assume that you're talking about this one. And you can get that one from the press release right there. Thank you, Wayne Johnson, also. Okay, So thank you, Wayne Johnson, for the bits. Thank you, Veronica Cure. Thank you, Ed Thompson. And thank you, Herleo, earlier for your sub. Thank you all so much. So I'm going to scroll up to the beginning and start looking for your questions. Let's see what all we've got. So Ed asks, I need that image. I found it. Sorry. Now you have that image. It is awesome. Okay. So Stormer John said, or Stormer Joe rather says, I know they don't know, but I wonder if dark matter also consists of atoms. So if dark matter consisted of atoms, it would be regular everyday matter and interact with light. And one of the annoying things about dark matter is it doesn't work and play well with the electromagnetic force, which means it doesn't absorb light. It doesn't give off light. It doesn't reflect light. It just sits there going, hi, I've got gravity. And it moves things and bends light like everything with mass and gravitational force interactions does. So this tells us that dark matter has to be something other than regular atoms, regular electrons, protons, neutrons. It's something else. And it's perplexing, but we're going to figure this out. We're going to figure it out. Let's see. Scrolling for questions. Veronica Cure says, why so many stories use Gaia data lately? Because Gaia's data is the best data out there. I need to do an entire episode on Gaia as well. Go back and find, we did an Astronomy Cast episode where we highlighted Gaia back when they were still in the process of launching the telescope. And we talked about how it does its data pipeline. This particular telescope is taking amazingly accurate data on the positions of stars, the color of stars, how they're moving, how they're changing in brightness. And all of this amazing data is allowing us to do science that we've just never been able to do before. Sammy, I'm just going to go with Sammy. Sammy asks, is there any more news? Yes, but I didn't do posts on people who won awards and commissioning of new telescopes that aren't yet seeing first light. Yeah, there was even more than what I showed. The news just keeps coming. Stella feeds off hugs, not Cheerios. That may be true, Paranor, but truly her passion is chasing things. Tennis balls, frisbees, toys, and then squeaking them until I need to go find headphones. She really likes to squeak things. So Hanny's Vorverb asks, are axions considered smaller dark matter particles than the ones they were looking for? I don't know. Hold on. This is me looking to see if there's anything I can quickly find. That I know of, we haven't detected axions yet. And it looks like we haven't. It's not that small of a particle, but we haven't found them yet. So until we find them and we know their characteristics, we won't know if they're dark matter or not. See you, Astro YYZ. Enjoy your day. So Larry, Weird and Proud, the pentaquarks that we've been able to find so far don't seem to be dark matter particles, but that is one of the directions we're pursuing. So Henny's Vorver asks, does all matter decay? We don't know. So there are a lot of theories that say the answer is yes, and that even protons given 10 to the 33 years will decay. Now, the problem is that 10 to the 33 years is experimental. Is not experimentally proven. And statistically, if we look at 10 to the 33 protons for 1 year, one of them should decay. And we've been watching for proton decays for more than 1 year in more than 10 to 33 protons. And so as near as we can tell, protons don't decay, but we may not have the theories right yet. Yeah. Someone found the squeaky toy clip. So Larry is asking, any news from FAST, the Chinese radio telescope? Just a teaser. No, I don't have anything. I'm sorry. So that is all I've got for today. I will be back with more tomorrow, and then tomorrow after that. And on Sunday, Annie will be here, our own binary ablaze. Thank you so much. Come back here. Come on, Stella. Come on. She's standing off in the background. Come on, Stella. Please pretend to care. I'm looking to see if I have a dog toy. I'm going to sacrificially offer her my hamster because she won't harm it. Stella, you want this? Come get the toy. Come on. Come get the toy. Get the toy. That's how you get her excited. She's like, no, I don't care. I don't care at all. My dog does not care. I'm sorry. Oh, she got it. So we found what she cares about. And now she's going to try and make the hamster squeak. Okay. It will make him angry. So Annie will be back at the same time, same bat channel on Sunday. And as always, we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are here to put science in your brains, and we are brought to you by you. Can you please help us out by getting the word out? Sub us on YouTube. That is free. Follow us here on Twitch. That is free. And just tell people. Check it out. It's just 30 minutes. Tell streamers you like. Take a break. Rate us, and we'll rate back. And let's all learn and do science together. Oh, and don't forget, you can help us map out the asteroid Bennu, because Bennu has a lot of rocks, a lot of boulders. But together, we have the ability to find the place that the OSIRIS-REx spacecraft can drop down and grab a sample of soil to bring back to Earth. So please help us make a science. And I'm going to look for someone to raid while the credits roll. And wherever you are in the world, have a fabulous morning, evening, afternoon. And remember, if the weather is nice, to go ahead and get outside and look up. Once again, thank you. Thank you for the bits. Thank you for the subs. And thank you for just being here, and bringing your curiosity. Bye-bye.